You just need to press the red button.
And you say?
Not when I say something. This will continue record for now. This says how many minutes it's going to record for?
26 minutes.
Yeah. So then it will keep on cutting down. If it stops, you have to press the red button again. Because it creates, yeah, it will break
Again.
Okay, cool. So, yesterday we talked about, what did we talk about? We talked about covariance,
Variance.
and correlation and all that kind of stuff, right? And everybody has an idea of what that is now? Okay. Now, today we will talk about, we will take the first steps to understand the basic linear regression model. Okay, because, as I said yesterday, covariance or correlation, okay, are measures of association. They don't tell you what the causal relationships are. So if you look at a firm, for example, and you find that the correlation between the firm's market share and the firm's advertisement expenditure is negative, that would mean either that the firm's covariance, because the firm's market share is falling, it is spending more on advertisement, that's why the covariance is negative, one goes down, the other goes up. Or it could also mean that the firm's advertisement quality of the firm's advertisement is so bad that if it spends more advertisement, the market share goes down. So correlation and covariances are measures of association. They don't tell you what causes what. They don't tell you whether the market share is falling because the firm's advertisement expenditure is falling because the market share is going up, or it's the other way around. That is, the market share is going down because the firm's advertisement expenditure is going up, and the advertisements are really not what people like, and therefore when they see those advertisements, they actually shift away from the product. Alright? Okay, so it could be both. So we have no way of knowing what is what. Right? To know what is causing what, we need a more formal statistical model. That's where we try and understand the basic linear regression model. Right? That's where we go for a linear regression. To understand linear regressions, we must first understand conditional expectations and conditional means and so on. So let me first give you some simple examples of what I mean by unconditional expected values, right? Unconditional means, and then go on to understand conditional means and expectations, and then maybe by the end of this class, we'll be somewhere around the beginning of a linear regression model, right? So as I said yesterday, if x is a random variable which takes values +1 minus 1 with the probabilities 0.575, then the unconditional expectation of x is
-1.
Right?
0.
Okay. Now what do we think of this expectation as? We said it is the limit of the arithmetic mean as the sample size becomes larger and larger and larger. This is where the average of the data goes as the sample size, as you have more and more and more data. Right? Okay. Similarly, suppose I roll a die. Okay, what are the possibilities if I roll a die? The number of the upper space of the die can be what?
6. 1, 2,
Yeah?
1, 2, 3, 4, 5, 6.
And what are the probabilities of each of these?
1 by 6. 1 by 6. 1 by 6.
Right? So what will be the expected value of x in this case?
1 by 6 into 1 plus 1 by 6 into 2 plus 1 by 6 into 3
Sure? And what is that number? Solve it and tell me what is that number. Please solve it, please don't watch the board. Yeah, but what is that number? 8.5. Right? This is equal to. Okay? Sure? Now let's have a slightly complicated sum. Now suppose I am tossing 3 coins. Okay? I am not tossing 3 coins. And let x be the number of heads that come out. I am tossing 3 coins. Let x be the number of heads that will come. So let me not toss the 3. X. Right, so my sample space will be, I can make that again. This will be one possible outcome. There are heads in all 3 tosses. Yeah? Let's across all the possible outcomes. How do you know there are only 8 possible outcomes in this case?
2 raised to
Because the first outcome can happen in 2 ways, the second outcome can happen in 2 ways, the third outcome can happen in 2 ways. Right, so your total outcome will be 2 into 2 into 2, 2 raised to 3, there will be total 8, you have written all down. Our random variable x is the number of heads on each term. So what is the value of x here?
3.
What's the value of x here?
2.
What's the value of x here?
2.
What's the value of x here? What's the value of x here?
0.
What's the value of x
1.
here? What's the value of
1.
x here? What's the value of x here? 1. Right. X is a random variable. Right? Now let me write the probability distribution of x and let me find out what is the expected value of x. So let me write x. What are the values that x takes? 0,
1, 2, 3.
So it takes 0.
3 also. 3.
What's the probability it takes the value 0?
1.
1 out of how many?
8.
8. So this becomes
1 by
1 out of 8. What's the probability which
3
takes
by
the value 1?
3 by 8.
3 times out of 8. Right? So this becomes, how many times does this take the value 2?
3 by 8.
3 by 8. How many times does this take
1
the
by
value 3?
1 by
1 by. So now, if I wanted the expected value of x, this will be what?
1 upon 8 into 0 plus 3 by 8
Plus 3
into
by
1.
8 into 1 plus 3 by 8 into 2 plus 1 by 8 into 3. Sure? Is equal to 3 by 8 plus 6 by 8 plus 3 by 8. Right? Which is what? Right? What is 12 by 8? 1.5. So the expected value of x is 1.5. What does this mean? It means that if you threw, okay, if you threw these 3 coins many times and calculate the number of heads on each toss, okay, then the average of the sample as the number of tosses keeps on increasing will tend towards 1.5 in the long run. 1.5 is the expected value. Now let me ask a more nuanced question. I will say I am not interested in all the outcomes. I am only interested in the number of heads on all three clauses, given that the first clause is a tail. So I am only interested in the number of heads on outcomes where I know that the first clause is a tail. I am not interested in all the outcomes. I am interested only in the outcomes where the first clause is a tail. I am not interested in any other outcomes, right? So therefore, which are the outcomes which will be of interest to me? This is going to be of importance to me. This is going to be of importance to me. This is going to be of importance to me. And this is going to be importance.
4 by 8.
Right? Now, what is the value that x takes here? 2. What is the value that x takes here?
0.
What is the value that x takes here? 1. What is the value that x takes here? 1. Which means that the distribution for x will change. Right? I have x here. Right? Okay? And so I have, so what are the various values it takes here now?
0, 1, 0,
1 and 2, right? 0, 1 and 2. It doesn't take 3 now. Sure. What is the probability to take 0?
1 by 4.
When does it happen? Here. Out of how many?
1 by 4.
Because there are only 4 possible outcomes. So this probability becomes 1 upon 4. Right? This probability becomes
2 upon 4. 1 upon 2.
and this becomes
1 upon 4.
1 upon 4. Right? Our number of heads. Number of heads given that the first outcome is a tail. Sure? Number of heads given that the first outcome is a tail. Therefore, number of heads that qualifies for the first outcome is a tail, but there are no heads, right? So h is 0. So x is 0. Right? Okay. Now, friends, if I want to find the expected value here, now let y be a variable which is the number of heads on the first clause. Sorry, number of tails on the first clause. Let y be the number of tails on the first clause. And x be the number of heads on all the three clauses. So what I have here is an expected value of x given that y is equal to 1. What I have here is the conditional, is the average value of x, the average number of heads on three clauses, given that the number of tails on the first clause is 1. Right? So x is equal to, so I have the expected value of x given y equals 1. Right? Which is now equal to what? Which is equal to 1 by 4 into 0 plus 2 by 4 into 1. Yeah? And how much is this?
1.
Right? So now I have unconditional expectation of x, which is 1.5. I have the expectation of x given y is equal to 1 is 1. Right? Sure? Similarly, I can have the expectation of x when y is equal to 0. What is this? This is called the conditional expectation of x. Conditional upon y equals 1. Because we put a condition. Right? We have put a condition. You see, I could ask this question like this. I could say, what is the... So I could study, suppose I am studying the expenditure, monthly expenditure of household in this time. I could say the average, and if I have a sample, and if I take a sample of say 1,000 households, I collect data on expenditure, I collect data on income. Right? And ask the question, suppose X is expenditure and say Y is income. I could ask the question, what is the average expenditure of the entire sample? So I have to just add all the expenditures and divide by 1,000 and get an answer. But I could ask a more nuanced question. What is the average expenditure of households whose income is 5,000 rupees? Then what will I do? I'll have to only take household income equal to 5,000 rupees and calculate an average. I can ask the question, what is the average expenditure of households whose income is 10,000 rupees? What is the average expected households whose income is 2,000 rupees? So I am putting a condition on income, right? Which then says that certain households qualify, certain households are not included in this question, right? So I have a conditional expectation, right? When my average across the entire sample, you have an unconditional expectation. So expectation x1.5 was that unconditional expectation. That's where the overall average would go to as the sample size becomes large. But I can also think of conditional expectation and conditional average. The conditional expectation will be the limit of the conditional average as the sample size becomes larger and larger and larger. Right? Sure? Is the idea clear? So let me find out what is the expectation of x given y is equal to 0. Who can find that? Expectation of x given y equals 0. What do you mean by y equals 0? Number of tails on the first toss is 0. Which means that what is there on the first head, first toss?
H.
A head, right? Okay. So which ones then qualify for you?
First, second, third.
Third and eighth.
The one which qualify for us in this case are this.
Then second one. Eighth one.
Right? Okay. Now here, what is x equal to?
3.
3. What is x equal to?
2.
2. What is x equal to?
2.
What is x equal to?
So that is not included.
That does not include it, you're right. This one. And what is x equal to?
1.
Right? So what are the various values that x will take now?
1, 2,
1, 2,
3.
yeah? And what is the probability that it takes the value 1?
1 by 1 by 4.
1 by
2 by 4.
It takes the value 2, 2 out of 4.
2 by 4. 1 by 4. 1. Total is
So what is the expected value of x?
2.
What is the number equal to?
2.
2. This number is equal to. So I have this equals to. Right? This equals. Sure? Right. So therefore you understand the difference between a conditional mean and an unconditional mean, a conditional expectation and an unconditional expectation. Right? Okay? Okay. So now, let me sort of try to draw this graph. So let me draw a y. Right? Now y takes the value 0 or y takes the value 1. Okay? On this axis, I will write the condition mean of x given y takes a particular value which I call yi. One particular value. Y takes the value 0 and 1. Right? So if y takes the value 0, what is the condition of a conditional expectation of x equal to y?
2.
2. So this is right? If y takes the value 1,
1.
so you get 1 here, 1. right? What does this line describe to you? It describes to you the conditional mean of y given x takes a the conditional mean of x given y takes a particular value. Okay? So it tells you what is the average value of x for a specific value of y. What is the average value of x for a specific value of y? Right? So if you specify a particular value y here, you will know what is the average value of x. So on. Right? Sure, this is called a conditional mean function. You call it the conditional, yeah. Sure. You see that when the conditional mean of y is 0, when the value of y is 0, the conditional mean of x given y is 2. Right? When y is equal to 1, the conditional mean of x given y is also equal to 1. So you get a point here. And if you join these 2 points, then you get a line which describes to you how the conditional mean of x changes for specific values of y, which we call the conditional mean function. Right? We call the conditional mean function. So I am now going to give you a very complicated something. Okay? I am going to give you a very complicated something. 2 or 3 complicated sums to do to clear this idea. The single most important idea probably. The law of large numbers and this. These are the 2 crucial ideas you need to understand to be able to understand regression models. Right? So now suppose we are tossing 4 points. Okay? Suppose we are tossing 4 points. Let x be the number of heads on the first 3 tosses. We are tossing 4 points. Tossing 4 points. Okay, listen carefully. Let x be the number of heads of the first 3 tosses. Let y be the number of heads on all 4 tosses. We are tossing 4 coins. Let x be the number of heads on the first 3 tosses. Let y be the number of heads on all 4 tosses. First, how many possible outcomes will be there? 16, no? 2 raised to 2 into 2 into 2 into 2. 2 raised to 4. Right, so let's all list those outcomes. So I will now list. Yeah? I just write it and write the single uniform fashion so you will get that. Yeah? Don't copy them, write to yourself. Which one is missing? How many you got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One is missing, no? I need 16. I need, don't copy that out from the board. Think and write. I don't want to say enough here as my stenographer. In your period. Yeah? Okay? Now we must write the values for x and y. X is the number of heads on the first 3 tosses. Y is the number of heads on all 4 tosses. So what is x here? How many heads in the first 3 tosses? First 3 tosses.
3.
Number of heads on the first 3 tosses, how many?
3.
3. And y is the number of heads on all 4 tosses. So what is y? 4, correct.
X is 3.
how much here?
3. Y is 0.
Y is
0.
Y is the number of heads on all 4 tosses, not the 4th toss.
Okay.
Number of heads on all 4 tosses. So what is y?
3.
Number of heads on all 4 tosses. 3. X is the number of heads on the first 3 tosses. Y is the number of heads on all 4 tosses. Why should it be 0, madam? Number of heads on all 4 tosses.
Head.
What is x here? Number of heads on the first 3 tosses. Y? You said 1. Stand up, right? You say 1. But you are not to the last value. You have to look at y is the number of heads on all 4 tosses. You have to count 1, 2, 3, 4. So how many? What is y? 3.